Okay, so the first question is, are the biosolids enriched with nitrogenated compounds? So I think you discussed something about the nitrogen loss during the process, but do you want to comment on this?
So biosolids have uh, quite significant amount of nutrients, all nitrogen, phosphorus, potassium, slightly less, but also some of the we called micronutrients such as calcium, sulfur, magnesium. So the nitrogen is mainly coming from the wastewater treatment. So um, we all consume nutrients, therefore that nutrients end up in our waste, human waste, and that ends up in wastewater treatment plant. We try to remove some of the nitrogen, but not all nitrogen is removed via wastewater treatment plant. That's why they end up ultimately in the biosolids. And when you pyrolyze it, some of the nitrogen will be released, um, and then eventually be released as NOx during thermal treatment process. But about 50% of the nitrogen will retain in biochar. I don't know whether
Okay.
I answered that question.
Yeah, yeah,
Is it?
yes,
Yeah.
yes, I think so. Yeah, okay,
Okay.
thank you. Yeah. So the second question,
So
I think you also mentioned about the, sorry, you have more things to add for the first question?
no. I'm looking at second question,
Yeah.
Karthik, and
So,
it says what measures researchers are taking to get government approval for land application after proofing no PFAS in biochar? So it's a very good question. So in Australia, we currently have no guidelines. So we have end of waste code for biochar done by our Queensland EPA recently, and end of waste code for biochar covers biochar from biosolids, but from also other resources. So if you demonstrate that it doesn't have a PFAS, then you still need to meet criteria for other contaminants. For example, heavy metals and some of the other contaminants also needs to
okay,
be considered.
okay,
The
okay.
third question is, does biochar production economically viable, self-sufficient to make profit, or it can work only if we get government subsidy? I think for biosolids biochar, I wouldn't say that it will make profit. Techno-commercial viability would not be that attractive unless you have a gate fee introduced, or some, like, if you say that how much landfill avoidance cost is achieved. So currently in Australia, landfill cost is somewhere around 350 to $400 a ton. It's going to increase in future, and if biosolids can't be applied to land and it's ending up in landfill, that time it will start making more commercial sense. But at this, as it stands right now, unless landfilling costs increase, you can't make it techno commercial. It's more commercially attractive. So that's why water industries will need to put money, and eventually they will ask us to really pay through our water bills. Okay,
Okay.
the fourth question is, does the higher ash content in the biosolids clog or foul the pyrolysis reactor? Higher ash content, majority of those ash content inorganics are going to be retained within biosolids, because those inorganics have relatively higher uh, um, devolatilization temperature um, uh, compared to the pyrolysis temperature. So they're going to retain in the biochar, but some metals may get devolatilized into the vapor phase. They may react. So, for example, alkalis and alkaline earth metals could react with chlorine and sulfur and make alkali sulfates and alkali chlorides type, or alkaline earth sulfates and chlorides type of aerosols that could foul. Siloxanes could also be a problem. The siloxanes is can be released as a nanosilica after thermal treatment, and they could also deposit on the surface, particularly where you do the heat recovery part. So yes, clogging and fouling is possible, and that's where you need to come up with some mitigation strategy there, either soot blowing or try not to not try not to let them deposit by going designing those thermal oxidizers and all that, heat recovery systems at much higher velocities and all that. So there's a lot of work required. So my point is that it's not going to be same as biomass pyrolysis unit. Biosolids pyrolysis will be significantly different when you scale up.
Yeah, thank you. Yeah, so we have two more questions for you.
Oh, right. So what happened to biochar after absorbing ammonium? Are they recovered through some reagents or will it go for landfilling? Well, it won't go for landfilling. We hope that now this ammonium is more added as a fertilizer, and if you're able to reduce the concentration of metals, heavy metals in biochar, or if you're able to apply at a lower rate, then that ammonium loaded biochar could be a good fertilizer replacement for number of soils. And ammonium loaded, then you have phosphorus also there, so it's literally nitrogen, phosphorus with some of the other micronutrients present there. That biochar could be a good uh, high value fertilizer.
Great.
And the last question is active metal enriched biochar is used as a catalyst for biogas cracking? Was ammonia TPD analysis done to evaluate the active sites of biochar? Um, no, I think that's a good question. So far we have looked at the active sites, but it's not only metal that plays in the crucial part in the reaction, but also the carbon that's deposited, particularly crystalline carbon that gets deposited from cracking of the methane. That also, in this case, acts as a catalyst. So the reactions are multiple reactions are occurring, and that's where I think we're still looking at more, doing more comprehensive mass balance and also understanding the role of metals there, and that as part of that really looking at identifying how much of the metal is active at different time scale, because initially they are active, but as we process through after several hours, we don't know what happens to them.
Okay, great, Prof. Kalpit. Actually, once again, we thank you for your time because actually it's your late evening time after work time, but still you have accepted our invitation to share your research. So we really appreciate that. Now we move
Okay.
on to Dr. Siti's questions. Yeah, Dr. Siti, you have two questions. Maybe I think you can answer one by one. Yeah.
Yeah, okay. Okay, thank you, Dr. Karthik. So the first question is, are we able to use reactive PYGC to differentiate biodegradable polymer versus synthetic polymer? Yeah, generally speaking, we can differentiate because in the example I've given just now, PHB co-HV is biodegradable polymer derived from bacteria. The second example is PBS co-BA is the chemically synthetic polymer, so we can differentiate basically in general. Yeah. So I
Okay.
hope the question one is answered. And for question two, what are the reaction mechanisms involved in this particular reactive PYGC? So basically, this reactive PYGC, our aim is to obtain the methylated product of each monomer unit. So with the obtain of this resultant methylated monomer product, it can be easily detected by the FID, for example, just now. So with that, a reactive PYGC with the addition of tetramethyl ammonium hydroxide. So that one is the solution that we use to catalyze the methylation process for the monomer of the polymer, so that we can easily get the pyrogram in the very clear or easy to calculate the based on the peak area. So that one, yeah, using reactive PYGC is much more easier to obtain the pyrogram, the results.
Okay, thank you.
Yes.
So if there are no, I think I just see two more questions. So let me see. Okay, one question for, if you don't mind, I will just read to make it keep it simple. So one question for Professor Kalpit. Can you give some insight about the carbon credit generation through biochar production. Carbon credits.
Yeah, look, I think I'm not an expert in that area, but definitely carbon credits are considered here. But the carbon credit modeling and acceptance is, I think, still on the way there. So I don't think currently in biochar, I mean, so here in Australia, you can apply for carbon credits, but I'm not sure what what sort of benefit it gives ultimately. And I think there's still a lot of loopholes in that modeling side, so people are working on further improving it. That's what my limited knowledge is, so don't quote me there, but yes, it
Yeah.
is, you can apply for carbon credits.
Okay, great. Thank you. Yeah, Dr. Siti, you have one more question. Like, how much pyro GC is standardized if the sample have unknown products? Example, like if they have like biological samples together with plastics and biomass, or if it is mixed one. So, what are the challenges in using like pyro GC for unknown sample analysis? It's a very gentle question. So, yeah, please share your experience on that. Yeah.
Oh. So for the analysis of unknown polymeric sample, is it the question?
Yeah,
The way
polymer
that I
together
understand.
with some biological samples, yeah, because you have biological sample
Hmm.
that's mixed with some biomass or like plastics.
Yes. Yes. So previously, I mean, normally what we do is we cross-check with the standard sample. So we use the commercially available standard sample, the polymer. Then we analyze together with the biological sample, bacteria cells. So the peak identification, which one is not overlap at the specific retention time, so that one is derived from the biological samples, such as bacteria cells. Another way is normally we cross-check using reactive PYGC-MS, mass chromatography. So the identification using mass chromatography can be done as well.
Okay, okay, thank you. So yeah, once again, on behalf of the Pyro Asia Forum, I would like to thank both speakers for sharing your research, and it was very useful session. And for participants, thank you for joining and with your busy schedule. Some of you could not join. We had like registered participants 80 over, but all did not join for live session. But we will share the recording with all registered participants and also the email contacts of both speakers and Dr. Jain if you want to interact with them directly for questions. Okay, so with that, we end today's webinar. So we will see you again with a different group of speakers and participants during our next webinar. And yeah, we look forward to seeing you at this Pyro Asia 2025 also. Okay, thank you all and bye bye.